Tonight we're looking for the smallest natural number n such that 6n is a perfect square. And so let me just write a squared. We're actually going to produce an a that ensures us that 6n is a perfect square, and also we'll construct a b such that 7n is a perfect cubed. In other words, we'll be able to find the a and b that gets the job done, and we'll show that it's the smallest possible one also. Okay. Now notice that 6 trivially is equal to the prime product 2 times 3, right? So that motivates this claim that n has to be in this form. If you had any other prime factors in here other than 2, 3, and 7, n would be bigger. We're looking for the smallest, right? Okay, so let's see, what can we try here? Well, one try that is correct, I think, is just to consider 2 cubed times 3 cubed times 7 squared. Okay. Now notice the 2 cubed, 3 cubed is automatically takes care of the perfect cube piece. Okay, because if we consider 7n, let's write out, if we consider 7n, okay, here's our n, and I've chosen these arrangement of exponents. That has no effect on the 2's and the 3's, right? But it does change 7 to 7 cubed. So what we end up with is 2 cubed times 3 cubed times 7 cubed. Remember, we had a 2 right here. Now it's 7 cubed. But notice that this is trivially a perfect cube. And if you want to know what that number is, 2 times 3 is 6. 6 times 7 is 42, right? So this would be 42 raised to the third power. So you see, just like that, we've constructed b equals to 42. Again, y'all, if I didn't make any mistakes on the arithmetic here, you can write it this way simply because 2 times 3 is 6 and 6 times 7 is 42. Okay. Now, what do we need to handle the 6n piece? Okay, let's move down a little bit. 6n. Now remember, 6 is 2 times 3. Okay, so that will just have the effect of incrementing this 3 and this 3. Okay, so you'll get 2 to the 4th. You see, that's the nice thing about this particular construction, is it turns these guys into perfect squares. See? Just this part right here is equal to 6 raised to the 4th power. Okay? Now, and of course, the 7 cubed remains unaltered, which is what we want. All right? Because this would be 7 squared. I'm sorry. Let me erase that. Okay, this remains is this 7 squared, right? Okay, again, we're doing 6n. This is our n right up here. I was just looking directly above. Okay, but this is equal to 2 times 3. This would just be equal to 6 squared. I'll just write it out like that for now. Right? 6 squared because 2 times 3 is 6, right? And then 2 times 2 is 4, laws of exponents, right? Times 7 squared. I could have done without this step probably, but this would be 7 squared right here. And so you see, we have a perfect square. We have a perfect square the way this is set up. Now, perhaps it would be better to write this as 6 squared times 7, all quantity squared. It's a little cleaner, right? In fact, it's better, right? Okay. You see, that's exactly what we needed to do right here. Our A would be equal to 6 squared times 7, folks. What's 6 squared times 7? Well, 6 squared is 36, and 7 times 36 is 21 plus 210 plus 42, right? So this is 252. All right, folks, we've finished what we set out to do. And again, I'm claiming n as the smallest possible thing that can do this, because any other prime powers that were cubes or squares would just make this a bigger number. They may work, but they wouldn't be the smallest, right? Okay. So again, here's the claim. It's this. The answer is this number, and I wouldn't mind leaving it that way. I think if you want to do the arithmetic on that, you get the number 10,584. Okay, so I'll keep both of those circled. In a competition, they might just let you leave your answer like that, just in the name of time. But anyway, there's the A that gets it done. This is equal to 200. This number is equal to 252 squared, and it's also equal to 42 cubed. All right, thanks for viewing.